Ella owes $25,000 in student debt at the end of her college career. The loans are collecting interest at an annual rate of 3.6% compounded monthly. In parts A and B, we want to know how much Ellen should pay each month if she wants to pay the loan off in 10 years, and what her total amount will be that she pays back. Parts C and D ask the same questions, but in that case, we're going to assume that Ellen is paying the loan off over the course of 20 years. So in Part A, the $25,000 is the PV. That's the amount of the loan when Ellen graduates. Future value is 0 because we want to pay the loan off. PMT is what we want to solve for. M is 12 because we're making monthly payments. The annual rate is 3.6%, which means I is 0.003. In Part A, we are paying the loan off over 10 years, which means 120 months. So plugging into the formula for a decreasing balance annuity, we get 0 equals $25,000 times 1.003 raised to 120 minus PMT times 1.003 raised to 120 minus 1 divided by 0.003. Okay, performing a couple of calculations, we get 0 equals 35813.92923 minus PMT times, next I'm going to calculate this quantity, and that gives me 144.1857231. Go ahead and check these. Make sure you're checking these calculations on your own, just to double check that you know the proper way to enter them into your calculator. So then to solve for PMT, I add PMT times 144.1857231 to both sides of the equation, and I leave this on the right-hand side. And then I need to divide both sides by that 144.19 approximately. And I get that PMT is equal to 248.39. Ellen will have to pay back approximately $250 a month to pay the loan off in 10 years. Part B asks, how much does Ellen pay back total? Well, she makes payments of $248.39, and she makes 120 of these payments. So calculating this, I'm going to get $29,806.80. So she borrows $25,000, but over the course of the loan, she's going to pay back closer to $30,000. Okay? Part B, or C and D, asks the same questions, but again, we are looking at over the course of 20 years. PV is still the same, $25,000. We want future value to still be 0. We don't know payment, but we know that there are going to be monthly payments. R is the same as before, and so is I. And T now, though, is 20 years, which means N is 240. So plugging into the formula for the decreasing balance annuity, I get the following. This is really the same calculation before, except now my exponents are 240 instead of 120, which is going to change the numbers somewhat. Okay, so let's do some intermediate calculations. Let's see, this is going to be 51,305.50108 minus PMT times I'm going to calculate all of this, and that gives me 350.74001. Okay, so then I need to add the PMT times 350.74001 to both sides, and then I'm going to divide by that quantity. And so let me just get caught up here. So my final answer for Part C is that the payment here is $146.28, which is quite a bit less than what we found in Part A, but again, that would make sense because we are spreading the payments out over a longer time period, so we're going to pay less for each individual payment. But in Part D, we want to know how much she pays back total over the course of the 20 years. So she makes payments of $146.28, 240 payments, and in this case, we get $35,107.20. So she'll pay back more if she takes longer to pay the loan off.